Hello guys. In this session we are going to learn recursion in a very non-standard unique manner. We are not going to follow whatever we get to generally learn in the standard tutorials and standard videos, okay? So this will be a totally different experience and I hope we all will enjoy it. So guys, today's session or today's stuff which topic which I'm going to discuss is nothing but recursion. So, guys, before starting the session, let's not go much into the technical jargon first. Okay. Like at the start of this session, I will be teaching a very important trick. Just keep that in mind, and you will be good with recursion for the rest of your life. So, let's get started. So, guys, recursion, just always imagine that you have a branch. Okay. The branch starts from here, then we make another node. Okay, we are just increasing the length of the branch like this. Node 1, then we have node 2. Slowly we make node 3, then we have node 4, then we have node 5. Just imagine something like this. Okay, so in recursion we will always have a branch. Point number 1, in recursion we will always have a branch. Okay guys, you can note it down also. We will always have a branch. Okay, always remember that. So I'm writing it here as well. For recursion, the trick is we will always have a branch. We will always have a branch. Okay, fine, nice. What happens is that we start from the top of the branch. Okay, second point, we start from the we start from the top of the branch. Okay, so okay, yeah. So we start from the top of the branch and we start moving downwards. First we come here at 1, then we come at what, 2, then we come at what, 3, then we come at what, 4, then we come at what, 5. So step number 3, always write that we travel we travel the branch from top to bottom. Always remember this thing. Always remember that. Okay. The fourth point, once we reach the bottom, we again travel in the upper direction like this. Okay, once we reach the bottom once we reach the bottom we travel again in upward direction. Okay, now guys comes the most important point. Whenever we are going down, it means we are exploring. Whenever we are going down a branch, whenever we are going down, it means we are exploring. We are exploring. Whenever we are going up, whenever we are going up, it means we are we have we have collected the final answer. We have collected the final answer, and now we are trying to send that final answer to the top. Final answer to the top. So what does this mean? It means that, okay, I was initially at node 1, then I reached node 2, then I reached node 3, then I reached node 4, then I reached node 5. Now when I'm again going from bottom to top, when I'm coming at node 4, it means I got some answer at node 5. I'm sending that answer to node 4. Now when I'm reaching node 3, it means I got some answer from node 4 and 5 and I'm sending that answer to node 3. When I'm reaching node 2, it means I got some answer from node 5, 4 and 3 and I'm sending that answer to node 2. When I'm reaching node 1, it means I got some answer from node 5, 4, 3 and 2 and I'm sending that answer to node 1. Obviously, I can take that answer and do some manipulation with the data of 1 and create my final answer as well. So always remember this strategy. This is very, very important. What happens in recursion, that we have nodes, we create a branch. Okay, for now I'm just creating simple branch. In like the next version of videos, this branch can keep getting complicated, but for now just chill out. Okay, actually the things are very, very easy, but I don't see people explaining them in an easy manner. People are creating like fear in the minds of young children for recursion and DP, even though this topic is so interesting, part of computer science. So this is the node 1. Okay, this is the node 2, this is the node 3, this is the node 4, this is the node 5, this is the node 6, 7, 8, 9, 10. Okay, I didn't even count 10, but these were exactly 10. Oh, thanks, congrats to me. So guys, so in recursion, you guys must have heard that we keep calling a function again and again, right? Yeah, so that thing is true, that you create a function, say say you create a function, you the return value is of type int, and say you write something in it. Okay, int x something, you do something. Okay, now what you do in this function, you do nothing. You create a base case. Say if x is equal to 0, you are saying that if this ever happens, if x is equal to 0, all you will do is return 0, nothing else. Very good. But if that is not the case, you can, let's say we are returning some value like x plus f of x minus 1. Okay, so what will happen, guys, is that you returned x, but f of x minus 1, the answer to this our program doesn't know. So our program again will send the value of x minus 1 here. Okay, so basically we are calling the function again and again until the x value gets reduced to 0. That's the basic crux of recursion. So let's go to a problem. Okay, so guys, in this problem I'm trying to find the sum of first 10 numbers. Okay, the program is working well. I had already checked it. First 10 numbers, the sum of first 10 numbers using recursion. So let me explain how we are doing it in such an easy manner. So guys, I have written cout f of 10. Even if you don't know C++, I am doing nothing. I am just printing. Cout means printing something, printing the value of f of 10. So guys, I'm trying to print the value of f of 10. Very good, very good, nice. So f of 10 I'm trying to print. So I'm calling a function f of 10. So the function will reach here. Okay, so what have I written here? Int f int vl. Okay, so vl is what? 10 for me. Vl is what? 10, 10, 10. Okay, now see, same as here. In the program I wrote x as vl. It does not matter, I can use any variable name I want. So currently x is 10, guys. Okay, so what is the, as soon as the program reads okay f of 10, what is the first condition which is coming in the function? If vl equal to 0, return 0. The current value of vl is 10, so this if condition will not be executed, it will be ignored. Then what is written below? Return vl plus f of vl minus 1. Basically basically what they're trying to say is that we are at node number 1. Okay, at node number 1 what is happening is we are returning what? Vl plus f of vl minus 1, vl plus f of vl minus 1. So this means, okay, vl plus f of vl minus 1. So guys, vl plus f of vl minus 1. So what will be the value at node 1? Let's try to figure out. Vl plus f of vl minus 1. And what is the value of vl, guys? What is the value of vl? That is the most important thing. That is what? Vl is 10. So 10 plus f of 9. 10 plus f of 9. F of 9. So where is f of 9? We don't know the value of f of 9. So a second call will be made for f of 9. And the code will go from top to here. Got it? This was for f of 10. This was for f of 10. Now for f of 9, the you can say the program logic, or the what we say, the flow reaches to second node. Okay, the second node is for calculating f of 9. I hope this much is clear to everyone. Okay, the second node is for calculating f of 9. So guys, the what will be the value of f of 9? So for f of 9, again the program comes here. Here it is written as if f int vl, same thing. Vl equal to 0, no, it is not 0, we will ignore it. And again we are returning what? Vl plus f of vl minus 1. So it means f of 9, what will be the value at this node? It will be 9 plus f of 8. F of 8. Okay guys, 9 plus f of 8. So what is f of 8? F of 8 is nothing but the third node. See, we are started from the top, we are now slowly going down. Okay, so for the third node means f of 8. What will be the value of f of 8? Same, if you go and check the function, you will come to know that f of 8 is nothing. See, vl is 8. If vl equal to 0, then you return 0, but vl is not 0, so ignore this if condition. Return vl plus f of vl minus 1, same as above. So f of 8 will be what? It will be 8 plus f of 7. As simple as that, guys. As simple as that. Now the program says f of 7, but program does not know the what is the value of f of 7. So what will the program do? Nothing. Program will just call f of 7 again to know the value of f of 7. Got it, guys? So it will go from third node to fourth node. Fourth node is the place where it calculates the value of what? F of 7. So f of 7 will be what? Nothing much complex. It will be 7 plus f of 6. 7 plus f of 6. Now you guys must be familiar what is going to happen next. Similarly, f of 6 we doesn't know. So it will come here and try to ask what is the value of f of what we say. Okay. So let me write the value of f of 6 here. So this is for f of 6. So what will be the value of f of 6? It will be 6 plus what? F of 5. Got it, guys? That's it. F of 5. Then f of 5 doesn't know. So f of 5 key value is at this node, next node. See, we started from 1, now we are reached 6th. Okay, top say bottom. We started from top, now we are reaching the bottom. So 6th is nothing but what? F of 5. Okay, so what is the value of f of 5? F of 5 is nothing but 5 plus f of 4. Okay, 5 plus f of 4. Now we are at the seventh node will try to calculate what? F of 4, because the program doesn't know what is f of 4. So the value of f of 4 will be what? The value of f of 4 will be uh, let me write. F of 4 will be what? 4 plus f of 3. Similarly, guys, at 8th place we will try to calculate f of 3. What will be the value of f of 3? Nothing much complex. It will be 3 plus f of 2. Okay, guys. Now after this, okay, let's think what should happen. We don't know the value of f of 2, so f of 2 will be calculated at node number 9. Okay, this is how the control logic or the program logic is going in recursion. Okay, when we write that program. So 9 is ninth node, will just calculating f of 2. What is f of 2? It is 2 plus f of 1. Okay, f of 1. F of 1 we don't know, so what will we do? We will come at the 10th node, which is calculating f of 1. What is the value of f of 1? Guys, f of 1 is nothing but what? 1 plus f of 0. F of 0. Now guys, what for f of 0? Okay, now how will the program calculate the value of f of 0? Let's see what the function says. The function says, okay, where is that? Yeah, int x. Let's assume x equal to 0. So if x is equal to 0, I've written in the function we have an if condition. If x equal to 0, just return 0. It means that the value of f of 0 will be 0. Got it, guys? That's the crux of the problem. That's the most important thing. Like, if we add the technical jargons here, people call it as the base case or something like that. So always remember that whenever you are returning some constant value, whenever you are returning, okay, seventh point, whenever you are only returning constant values, that's where the branch ends and you start going up, start the process of upward direction. Upward direction, guys. If you are watching this video and really want to improve, please mention all this program code and this 7 points in your diary. Okay, so guys, what was the most important thing? The most important thing is that whenever you get the constant, see, here, if x equal to 0, you are returning a constant value 0. But when it was not 0, what you were returning? You were returning vl is constant, but f of vl minus 1 is not something, what you can say, it's not a constant number whose value you already know. You are writing a function f of something. Got it? So whenever you are doing something like this, na, this is for, you can say, you're exploring or going down, something like this you can write. Okay, you don't need to write that as well. But whenever you are say returning a constant, it means now the process starts of sending answer upward. So guys, I explained in the first half that now we will start the process of sending answer upwards, because for vl equal to 0 you wrote what? Return 0. Now there is, now you did not tell the program to return some f of value, so it will not go down below. Okay, so as you were returning just 0 here, so the branch stops. Okay guys, the branch stops. Here you are returning what? F of 0 is what? 0, nothing. F of 0 is what? F of 0 is what? 0. So now we so what happened is that we had a branch from 1 to 10. Okay, we went from 1, then we reached till 10. In 10 we get a constant value of 0. So now we will go from 10 till 1. Okay guys, from 10 till 1 we will go. So let me draw it up here again. So right now I am at the 10th branch. What is the answer? I have already written it here. Okay, so for the 10th branch, the answer is what? 1 plus f of 0. F of 0 is what? 1. F of 0 is what? 1. Okay, so the answer at the 10th node will be what? 1. Got it? F of 0 plus 1. Now, at the ninth node, you can see that the answer which we had written, we can just check out what we had written 2 plus f of 1, 2 plus f of 1. So guys, see, the answer is now propagating upwards. 2 plus f of 1. What is the value of f of 1? That answer you already calculated. It was what? 1. It was what? 1. So I told now, whatever answer you get from below node, you propagate it upwards. So f of 1 ka value is what? 1. So this 1 value is sent now up in the upwards direction. So 2 plus f of 1 is what now? 3. Got it guys? It's as easy as that. For the eighth node, what we had written, I still remember. If you guys don't remember, you can go back and check. But I'll tell you what we had written. We had written here, if I remember correctly, 3 plus f of 2. 3 plus f of 2. So guys, what is the value of f of 2? We already calculated it here. Okay, 2 plus f of 1 was f of 2, and f of 2 is what? 3. So we got, till now we got the answer 3. Now we'll propagate this answer up. So f of 2 is what? 3. So it will become what? 3 plus 3 is what? 6. Got it guys? Similarly, you will do it for the 7th node. At the 8th node, you have answer as 6. Okay, means it is 1 plus 2 plus 3 ka sum basically. At the 7th node, we had written what? We had written 4 plus f of 3. You guys can like rewind the video and check what was the value on the 7th node. 4 plus f of 3. So guys, 4 plus f of 3. 4. And till now we are now going in the upwards direction, not downwards direction. So we have calculated all the answer. What was f of 3? We have calculated till here 6. So 4 plus 6 is what? 10. What is it guys? It's 10. It's 10. Okay, it's 10. So at the 7th node, now I'm not drawing the full picture. Just assume we reach the 7th node. Then we have to reach 6th node. Then we have to reach 5th node. So at 7th node, the answer is 10. Okay. And at the 7th node, what was the, I was writing 4 plus f of 3. So 4 plus f of 3, it was there. Now at the 6th node, it was what? Previously it was okay, you can always go and check what was the value of the 6th node. It was 5 plus f of 4. We can see here. Okay, 5 plus f of 4. Okay, it is 5 plus f of 4. Okay guys, I hope this is clear. So f of 4 we have already calculated here at the 7th node, which is what? 10. It is what? 10. Now we are going from down to up. So whatever answer we got till down, we will now propagate it up. So 10, 10. So this is the value 10. Okay, so f of 4 is what? 10. So 5 plus 10 is what? 15. 5 plus 10 is what? 15. So currently we got the value till the 6th node. Similarly, this 15 value will be propagated here as well. Fifth node ka value was what? It was 6 plus f of 6 plus f of 5. Okay guys, 6 plus f of 5. See, so much, the recursion is so much interesting. A man can spend his whole day. Okay. So what is the value of f of 5, guys? Okay, so f of 5, we just calculated it at the sixth node, and it is nothing but 15. So we are going from down to up. The 15 value from the down, it's coming here. So f of 5 is what? It is 15. So guys, what is 15 plus 6? It's 21. It's 21. So guys, currently at the fifth node, you have 21. Okay. Now we'll go to fourth node, then we'll go to third node, then we'll go to second node. Then at the first node, we will again reach where we were earlier. Okay. We'll go from here, we'll reach here. When we reach the first node, we will have our final answer, which is the sum of first 10 numbers. Okay, guys. So at the fifth node, we have 21. Now let's just directly calculate. Okay. So at the fifth node, what I was adding? I was adding 6. Okay. So now we'll be adding 7. Okay. So 21 plus 7, what it will be? See, so here I'm adding 7 and 21 is coming from here. Guys, you now know the process how 21 is coming here and why I'm adding 7. Because the value of 4 is what? 7 plus f of 6. Got it, guys? Got it? I hope this thing is pretty much clear to you. So at the fifth node, we calculated f of 6. F of 6 was a 6 plus f of 5. And what is f of 6? 6 plus f of 5? 6 plus f of 5 is 21. So 21 now goes above and it becomes 7 plus 21, which is what? 7 plus 21 is 28. Okay, guys? 7 plus 21, which becomes 28. So node at the node 4, value is 28. What is the value at third node? The third node is asking for what? F of 8. F of 8 is what? The program knows that. Okay, program main dump. So the value is 8 plus f of 7. Okay, everyone is really smart here. So, and God is also always with us. So add 8 plus f of 7. Okay, 8 plus f of 7. 8 plus f of 7. So f of 7, we have already calculated it here. Now from down, it will go here. What was f of 7? It was 28. So f of 7 comes here. It is 28. What is 8 plus 28? Okay, guys. So it becomes 36. Okay, guys. It becomes kind of 36. Then similarly, like you will try to, when you reach here at node number 2, you will try to add 9 and it will become, see, 36, 46. Okay, 45. At node number 2, you will have 45. Okay. So at node number 2, okay, let me write it down. At node number 2, the value is 45. What is f of 1? F of 1 is nothing but, we wrote it down there once upon a time. F of 1 was not VL plus V, F of VL minus 1, which is 10 plus F of 9. So what was F of 1? Sorry, what was the value at node 1? F of 10. F of 10 is what? 10 plus F of 9. So at node 1, this is our node 1. At node 1, the value is what? F of 10. What is the value of f of 10 which we are trying to calculate? It is nothing but what? 10 plus f of 9. F of 9 I have already calculated. Now it is going from down to up. What is f of 9? It is 45. It is going from down to up, propagating the answer towards up, propagating the answer in the upward direction. So 10 plus 45 is 55, and that's how we are getting the answer 55. So that's how easy recursion is. Okay, guys, so make sure you remember all these things I taught. In the further recursion videos, I will explain how this recursion can get the branch can get more and more complex. Now the branch was like in a linear fashion. Okay, from each node there was only one node coming out, so it was easy to understand, easy to travel. Always remember, in recursion you start from up, you go till down. At down, you find the first constant answer. Using that, you propagate the answer towards the upwardness. Okay, and when you reach again at the top, you get the final answer. You can check it here, guys. I'm returning f of 10, which is the final answer. Okay, guys. Now apart from that, the other thing I would want to say is, see, in the future videos, the branch can get heavier like this also. Okay, so then in those if branches are like this, always travel down. Then as the down thing gets over, you again go up, then you again go down like this. You basically make a boundary. You can imagine that this is a tree and you're trying to make a boundary. If you try to understand recursion in this way, now you will become very very strong, and even your DFS and graphs and tree concept will also become very very strong. Okay, so currently I'm not going into that jargon. Okay, yeah, one thing I did not discuss. See, so let's discuss the technical jargon. People generally ask, what is the space used by recursion? So whenever recursion is happening, the program at the back is using some stack space. Okay, so if we talk about the technical stuff, they call it as stack space. So basically, what what, see, there were some number of, there were some number of nodes created, okay, in recursion. In the program, you can just assume that some number of nodes were created, and at each node some answer was stored, right? So the program needed some space. Program needed what? Space. But the best thing is, what does the space is different at different time, okay? When the f program was at f of 10, the space we used was what, you can say one node. When you came here back, the space used was what, two nodes, then three, then four, then 10. When you reach the 10th node, the space used was what, 10th, 10 nodes. But now as soon as you start going up now, the program forgets the memory, the last memory. Because it is of no longer of use. So as we start going up, the usage of space keeps on reducing. For example, let me explain in a better manner. Say you have five nodes, okay? In a recursion you have five nodes, so you can say that space is what, five nodes were used, five nodes. That in space complexity you always have to say the maximum space used, okay? So five nodes were used. How it happened? Initially here only space one was used. When you reached here, the space two. When you reached here, space three. When you reached here, space four. When you reached here, space five. Once you go from up to down, now is the time to go from down to up, okay? Down to up. So when you reach at node 4, the stack space was 5, but as soon as you go here na, the program pops out the latest node. It pops out the node number 5, because now it is not needed, guys. You got the answer from here na. Now why will you keep that node 5 with you? So it will pop out that space. Now you only have four boxes. Just imagine, now you only have four nodes. When you come from 4 to 3, you only have three nodes. The last two nodes program just forgets it, okay? It kicks them out of the memory. Similarly, when you reach at the top again, you only have like one space, or you can say zero space, whatever, okay? So the space complexity you can say is O of what, n, where n is what, the number of calls, or the number of, you can say the number, okay? Currently you guys are beginners, so let me explain. You can say the length of the branch, length of the longest branch, okay? What is the space complexity of recursion? O of n, where n is what, n is nothing but what, length of the longest branch, length of the longest branch, okay? Length of the longest branch, okay? Now, so it can happen that, say our code was something like this, okay? So when you start from here, okay, here the space taken is 1, here the space taken is 2, here the space taken is 3, here the space taken is 4. You go from 1 to 4, now you start coming up. Here again the space taken is 4, you go up, it forgets the fourth node, it becomes 3, then you go up, it becomes 2, okay? Now it starts going down in this direction. Again the space taken is 3, space taken is 4, space taken is 5, space taken is 6, space taken is 7. You go up till here, space taken again 7, 6, 5, 4, 3, 2, 1. So one branch is what, of length 4, another branch is what, of length 7. So what will be the space complexity here? It will be 7. Space 7, 7 at maximum. And one time in recursion only 7 places were used. Never say 7 plus 4, because when we were here in recursion the space was 4, then we removed these two nodes, then we started creating this new space for 2, 3, 4, 5, 6, 7. So always remember, in recursion you can say, if you're creating this tree, the length of the longest branch from the top node, or people call it in, if you use the technical jargon, people call it the root node. The longest distance from the root node will be the space complexity of your recursion. Always remember that. And to add some more fun to it, people call it as recursion stack space. Okay. So guys, to be serious, it's not about fun. I just teach my students in such manner, okay? So I hope you guys like this session on recursion, and I will be discussing more and more advanced stuff in the coming sessions. Yeah. And yeah, always make sure to visit my website, basic Q&A, because like my website has like having daily 100k, or you can say 100k users, or you can say 1 lakh visitors daily. It is mainly made for the peoples who are into coding stuff and are preparing, okay? Like if you want to go through any online assessment which are asked in any of the top companies, you can go and visit and get 100 plus questions and answers which were asked, okay, previously. Same goes for the interview experiences, okay? So my team keeps on updating them on a regular basis, and we also have a lot of community support, so it really helps. So that's it, guy. Thank you so much. I'm now stopping the recording.